go. Okay, linear models and rates of change. We'll start with slope. You all know how to find the slope. But again, back to the question, why is the slope of a vertical line undefined? Eric.
You can't divide by 0.
What, you got to be more specific.
Alright, so the change in y is like, wouldn't that be 1 if it's changing? No, wait. I'm thinking, yeah, it's changing, it's going up by a certain amount.
Well, I have problems with pronouns. What's it?
An integer, a number, a real number, any real number.
Okay.
And then it's not changing across the x any, so that would be zeros, and you can't divide by 0.
Everybody get that? Yes?
Yes.
Okay, good. So then what would be the slope of a horizontal line, Eric?
0,
Why?
because it's 0 divided by 1.
Good. Or 0 divided by some number.
Or, yeah.
Good. All right, that sums that up. Positive slope, 0. Negative slope, undefined. Okay. Can't divide by 0. Okay, the change in x is 0, so therefore you're dividing by 0. 0 divided by anything is 0. Change in y here is 0, so it's 0 over some number. You know all this, right? Hopefully you're not even writing this down. Equations of lines. We're going to deal with 2 equations of lines. I know a lot of you like y equals mx plus b. And if you're a strong advocate for y equals mx plus b, I'm going to try to talk you out of it. And we're going to work mainly with point-slope form because it's easier. So point-slope form, you remember that. Y minus y1 equals m times the quantity x minus x2. In point-slope form, you need 2 things. What are they? A point and a slope. Good. M is the slope. Y1 and x1, y1 is the point. So, what's the equation of the line with a slope of 3 passing through the point 1, negative 2? Awkward moment of silence. Luke.
Okay, so you'd have y plus 2,
Y plus 2?
well, y minus negative 2, whichever you prefer,
Y plus 2.
equals 3 parentheses x minus 1.
How do you do? Good. Golf clap. Excellent. Easy. Suppose we don't have a slope and a point. Suppose we have 2 points. Then what do you do? And then? Then you do that. Good. Get rid of that. Told you this would be easy today. Ratio and rates of change. This might be the new thing. Do you know the difference between a ratio and a rate of change?
Yes.
Yes? Who said yes? What is it?
Ratio is a number compared to another number, while a rate changes.
Faded off there at the end. Started strong and then.
A rate of change is like slope, where a number is divided by another number.
Okay, so give me an example of a ratio.
3 to 2.
Just 3 to 2.
Yeah.
Okay, give me an example of a rate of change.
3 over 2.
Aren't those the same thing?
No.
Help me out, peoples. Are we okay? How do they differ? If I said there are 15 boys to 18 girls in here, would that be a ratio or a rate of change? Ratio?
And then you say 15 out of 18 girls have brown hair.
Oh, and then they turned on him like, no!
Oh, yeah.
The only difference is the units of measure. If you're comparing the same thing, you get a ratio. Okay, 3 dogs to 2 dogs. That's a ratio. If you're comparing different things, you get a rate of change. This isn't a big topic. It's just I want to make sure that you understand the comparisons here. 3 dogs to 2 dogs versus miles per hour. Rate of change for us is most commonly going to be expressed as some type of slope. Okay. However, you could also use it as a ratio. I have a couple examples to show you the difference. Population, you can read, I'm not going to read that to you. But we're talking about the population of Colorado, which drastically increased in the year 2014. Somebody want to tell me why? Serious question?
Legalization of recreational marijuana.
Well said. Yep. You can get some pot there. Population went up. Completely irrelevant to this problem. I just thought I'd mention that. Okay, so rate of change then, we're comparing population, aka people, to years. How much did it go up? And so you get that rate of change. And then you can do the calculation if you'd like, and you find out that it's 83,800 people per year from 1995 to 2005. The population growth from 2005 to 2015 would be higher. It would not be a linear model. A lot more people moved to Colorado recently. Okay, so rate of change, again, different units, as opposed to something like this, where you're finding the slope of that ramp. The vertical distance on that ramp is measured in feet. The horizontal distance on that ramp is measured in feet. So when you compare that and find out the slope, you're going to end up with a ratio, not a rate of change. For the most part, it's the same thing for us, but it's important that you understand the, we did that, okay. So it has a slope of 2/7. No units there because the feet cancel. When you compare people to years, people don't cancel with years, so it has some units on there. Okay? Any problems with that? Awesome. That's about the only new thing you'd see. Some basic graphing stuff. We're going to do two things. Here's a graph. What's the equation? Here's an equation. What's the graph? I think this is a little bit easier for you now. You'll get better at this through practice. I'll give you a graph. You'll recognize, oh, okay, that's a cubic graph. You'll recognize where the intercepts are. You'll recognize where what's called the max and the min are, and we'll start to get some calculus involved. And I think you did a little bit of this last year, did you not? Yeah. Yeah, okay. It'll be a little bit easier this year because I have a more algorithmic approach to it. Do you understand the term algorithmic? Yeah. Good. Does anybody not? All right, beautiful. Slope-intercept form, not a fan, but sometimes useful. Y equals mx plus b. How many people prefer slope-intercept? Oh, hold on, let me ask a question. How many people prefer slope-intercept versus point slope? Slope-intercept fans? Point slope fans? Those of you that don't really care. Okay, thank you for being honest. I'm going to try to get you away from this. You will use it occasionally, but for the most part, point slope is where it's at. The other thing you don't want to do, and I'll say this about a gabillion times before May, whatever, if I have an equation in point slope form, you do not need to convert it to slope-intercept. That is an acceptable answer for AP. Because what happens is if you decide, oh, I'm going to answer in slope-intercept form because I like slope-intercept form, so you get y minus 2 equals 3x plus 3, and then y equals 3x plus 5, you're in trouble. I'm sorry?
Where did you get the plus 3?
I purposely made a mistake. Okay. That's my point. This is fine. Full credit, you get the point you need. This, you're in trouble. They're not going to give you the point. They're going to look at your final answer. So if you can stop here, stop here. Don't do extra work. For some reason, people can't get that out of their system where they can't see that as an acceptable answer. And here, it works just fine. So, stop at point slope. But if you have to use slope-intercept, you can do it. Let's graph these three things, and make sure that you understand them. All right. What's that graph look like? It's a line. It's a line. Has a y-intercept of 1. Slope of 2. Up 2 over 1. Straight edge. So that doesn't happen. Don't forget arrowheads because it's a line that goes on forever. Okay. Easy. Next. y equals 2. People screw this up all the time. Is that y equals 2 or y equals 2? Correct, it's y equals 2. It's all the values on the graph that have a y value of 2. Horizontal line. Oh, my pen just stopped working. There we go. Got caught up there. Y equals 2. And then the last one. What about that guy?
Well, to make it easier, so can't you convert it into slope-intercept? So it'd be 3y equals negative x minus 6, and then divide by 2.
Question?
Would it be negative x plus 6? Just move to the other side.
Correct.
Oh, yeah.
Good. Again, I made another mistake purposely. Down 1 over 3. 1, 2, 3. Okay. Again, like I said, Algebra 1 stuff, so this should not be rocket science, right? Yeah. Good. Okay. Oh, perfect timing, I believe. Let's check. No, we're not done. But the last stuff is parallel and perpendicular lines. You should be okay with that. What can you tell me about parallel lines? Same slope. What about perpendicular lines? Opposite. Reciprocals. Have a nice weekend. Day 3.